Today, we've got some rucksacks, and if you didn't know what those were, there is a Wikipedia link for what a rucksack is. It's more or less just a backpack. The summary of the problem is that these elves are supposed to pack these in a certain way so that there isn't duplicates across the sets. And our job is to essentially find where all the duplicates are and give it some sort of score. Now, the score is based off of some sort of prioritization that goes through the A to Z, lowercase a to Z uppercase, and then you print out the sum of the priorities of those item types that are overlapped between the two compartments. So it sounds like a lot of work, and it really is. It's a lot of busy work. And I'll go through maybe a quick example on what is happening here. So this is one of the rucksacks. Each line is a rucksack. And of the two compartments, they split it exactly down the middle for each one. And one side is one compartment, and one side is the other compartment. And you have to figure out what overlap exists between them. So right here, it says the only item type that appears in both compartments is lowercase p. So you can see there's a p on this side, and then there's a p right here. So we would take that p, go down to here, and assign it a priority, and then we add that to each one of these rucksacks. So it looks like we had p, l, p, v, t, and s. And the sum of those was 157. So if this was our input, our output would be 157. Now the output for this one is a little bit longer than that, but we'll go through it together. Let's quickly run over to Paint and explain the algorithm before we get into it. So there's going to be a couple assumptions that we do while making this. First, we'll say that we believe that all of them are even sets. So there aren't any rucksacks with odd amounts. So we can always split it right down the middle. The other thing that we want to set up before we even start coding is some sort of list to basically convert ASCII characters into these values. Now there's a very easy way to do it, which is go into create a function that essentially converts for you. So it'll just have a big list. It'll be like A, B, C. Those would be the letter equivalents, but the list in your program would instead be 1, 2, 3. This gets a little complicated because then you have to maintain like the combinations of the list. So you'd have like maybe a dictionary. So it would be key value pairs. So like A1, B2, C3, and you could do this. Like this is a valid solution. But once you start doing things like functions and sending things in and creating local variables, you would be creating this list every single time. And it doesn't sound like a lot. Like what it would be 52 values or 52 dictionary keys, but it has to work for every single line. Every single time it finds a match, it would be running through this, and it does get kind of complex. Now, if you were doing it all in one main function, you could just say, here's the dictionary of values right at the top of main, and do the whole dictionary equals, and then do the whole list, A1, B2, and that would be fine. That would be a good way to do it. Then you would just quickly reference this dictionary. But like I said, once we get into functions, this would become a local variable that is created every single time that function runs. And because we don't want to just create garbage code while we play this advent of code, you know what? Maybe we will make the garbage code version, and then I'll explain why it won't work. Yeah, that makes more sense. That sounds like a better way to explain these things. So I've created both, just so that we can kind of talk about it a little bit better. So as I was saying, you could make this dictionary and have all of your code in main, and then just reference character values. So if you had an A, you'd say, if the key is this, then the value is this. And you can do that very quickly in Python. It's not very time-consuming or complex in terms of, your algorithm. We'd have to do that for 52 different values, so it would be quite a long dictionary. You can store it somewhere else and just reference it, but it's really just not ideal. I call it the silly way, because it would work. And in this context of, I want to get this done as fast as possible to be on the leaderboard, I bet you this is what they're doing. The longest time it takes to do this is, just filling it out. But the other option is to use ASCII values, and I'll just flip back to the web browser. And sorry about the blurriness, but what you could do is say, well, I know that character A, capital A that is, has a decimal value of 65. And I know that this one, the letter A, but small, is at 97. So if A needs to be 1, then I can just subtract 96 until I get to an uppercase character. So you can do that very quickly in a function and just say, well, convert character to score, give it a string, and then in that string, just do an is upper. And if it is an upper, then subtract 38. Otherwise, it's a lowercase letter and you subtract 96. return that score. You can also simplify this down without the else statement and just do that, because if it doesn't hit this one, then it's a lowercase. Now the rest is pretty simple. We just do what we've been doing this whole time. Just grab their input file, input.txt, make sure that's in quotes. We'll set it on read mode. All right, and with a bit of finagling, there we go. So we've got the line being stripped. I forgot about that part. Took half the array, make it into an integer. We could do this in here, and I think that was in there before, but I decided it looks a little bit better if you just set it up like this. You can see where the colons are much better when you don't have all of the math in the same line. So now all we have to do is say for character in left side, if character in right side. We'll use the proper way, bring this in, and set this up at the top. So we want some sort of rolling summation. Rolling sum equals 0. Let's assume we don't count it twice. So then we need something else to keep track of what has been checked already. So let's just make something here. We'll do something like found character, found duplicates equals list. And we'll just put another check in here. If character not in found duplicates, then we increment, and we'll add it to found duplicates.append character. I don't think this will matter too much in terms of performance, but it is something just to keep in mind. And if this is wrong, then that's fine. We'll just get rid of this, and it'll make the logic simpler. Much rather do it more complicated and then make it simpler afterwards. Now we have to update this because I was holding just a random value in there. So we'll do rolling sum and rolling sum. And here we want to put in character. All right, so we can try this out and see if it works. And if it doesn't work, then I'm getting the feeling that this extra logic is just a little bit overkill. So let's run this and see how it goes. 7,990. Okay, let's give it a go. That seems low. Usually they give us much bigger numbers, but we'll give it a go and adjust it accordingly. So 7,990, submit. There we go. Okay, so we didn't want to do duplicates. That's good to know. We made the right choice. Very good. So let's check part 2, and again, if it's too much, then I'll just do it on my own. Okay, I don't think it'll be super complicated, but the wording is really, really weird. So in summary, we need to make it into groups of 3 instead of groups of 1, and we're looking for a common letter across all of the characters. That'll be their badges, the elf badges. And those would then have some sort of ASCII number value, very similar to what we had before, and then we want to summate those instead. So in this one, I believe V was not it. So we try V, and it looks like V isn't in this list, so we would get rid of V from this list until we find, let's see, it was R. So this R is here, that's their badge. There's an R here, that's their badge, and then there's an R here. Now for this one, I think I'll update this code so it pulls everything out of the file and into a list, and then we can use that list as a bit of a proxy for both. So let's just quickly update this code so that it'll have some sort of file list component. So if we give it a step count of 3, then it'll move by 3 each time. So we can say first line is equal to file list at position I. Then we'll have I plus 1 and I plus 2. So now all we have to do is flip through first line, making sure that it's in second line and third line. But you know what? We don't even have to do that. We just have to find it, so we don't have to remove. We can just keep going. So if it's not there and it's not there, well, if it's there, then we want to do this. We want to grab this rolling sum, throw it in here, and let's just quickly rolling sum equals 0, reset that for part 2, and we'll want to print rolling sum after this. Now, if we find that it's not, then we'll just have an else case for each, and it'll just say continue and continue. That won't save too much time, but it does kind of get the point across that we only have one case that really works, and the rest we don't care about. So that should do it. So just to recap, we take first line, compare it to second line and third line, which are the next 2 lines in the list. Don't need found anymore. And for each character in first line, we check if character is in second line, and then we check if character is in third line. If it's in all 3, then we can update rolling sum. And probably we want to hit a break statement right here so that it pops out of this first line check, and moves on to the next for I in range count 3. There we go. Let's give that a run. I think that's basically correct. Hopefully that's correct. All right, so we've got a much smaller number now, but I think that is in line with, it's about the same size. Let's go with 2602 as our number. See if we get the correct answer. There we go. First try on both. We've completed day 3. So that was Saturday's. So tune in for Sunday next, and then Monday will be hopefully either Monday or Tuesday. It starts to back up. Maybe I'll skip one and just throw it on the GitHub whenever I find one that I don't like or don't want to share. But this one's going on to the YouTubes, so thanks so much for watching, and I will see you in the next one.